Stars appear as twinkling points of light due to their immense distance from Earth. The Earth's night sky gradually transforms into the infinite expanse of outer space. The seamless panning motion emphasizes the continuous connection between Earth and the universe. Vast fields of stars illuminate the infinite expanse of space. The stars' radiant glow reveals the immense scale and beauty of the universe. The continuous journey through space unveils the boundless nature of the cosmos. Distant galaxies appear as shimmering lights, enhancing the depth and scale of the cosmic landscape. The shimmering effect of galaxies is due to the combined light of billions of stars and interstellar dust. These distant galaxies provide a visual representation of the vastness and complexity of the universe. Nebula clouds are composed of interstellar dust, hydrogen, helium, and other ionized gases. These clouds drift gently, creating a soft, ethereal motion across the cosmic frame. Nebulae serve as stellar nurseries, where new stars are born from collapsing gas and dust. Shooting stars create fleeting light trails across the vast expanse of deep space. These light trails enhance the visual sense of movement and dynamism within the scene. The gentle drift of these celestial events adds a subtle layer of activity to the static backdrop of space. Cosmic dust particles enhance the visual texture and realism of the deep space environment. The distribution and density of cosmic dust contribute to the overall depth and complexity of space visuals. Detailed particle rendering reveals the intricate structures and light interactions within cosmic dust clouds. Radiant starlight beams emanate from distant stars, piercing through the darkness of deep space. The beams of starlight illuminate the scene with a soft, ethereal glow, creating a serene and majestic atmosphere. Starlight travels vast distances, carrying energy and information across the cosmos. Binary star systems feature two stars orbiting a common center of mass. The slow rotation of twin stars creates a visually captivating spectacle. The gravitational interaction between the stars influences their orbital paths and stellar evolution. Parallax motion enhances the perception of depth within star fields. The differential movement of stars simulates three-dimensional space. This effect provides a more immersive and realistic visual experience. Lens flares can add realism and visual appeal to starlight in space scenes. Subtle lens flares enhance the perception of light intensity and source. Carefully placed lens flares can create a more immersive and visually interesting space environment. The animation's core aesthetic emphasizes a calming and meditative visual experience. Slow, deliberate movements are key to maintaining the animation's serene atmosphere. Serene visuals contribute to the overall calming effect of the animation. The spiral galaxy is characterized by its distinct spiral arms emanating from a central bulge. These spiral arms are regions of active star formation, marked by the presence of bright, young stars and nebulae. The overall structure of a spiral galaxy is maintained by gravitational forces and the galaxy's rotation. The galactic core emits intense light, illuminating the surrounding space. The brightness of the galactic core reveals the intricate structure of the galaxy. The galactic core is the central and most luminous region of a spiral galaxy. Spiral galaxies exhibit intricate arm structures composed of star clusters and nebulae. The arms of spiral galaxies are sites of active star formation. Star clusters within the galactic arms contribute to the overall luminosity and structure of the galaxy. Nebulae are vast interstellar clouds composed of gas and dust. The colors within a nebula originate from ionized gases emitting light at specific wavelengths. Nebular gas movements are driven by stellar winds and gravitational forces. Gas clouds drift slowly, creating a sense of depth within the nebula. The drifting motion of gas clouds enhances the immersive experience. The nebula structure is defined by the movement and interaction of these gas clouds. Nebulae exhibit subtle color variations due to differing elemental compositions and ionization levels. These color differences reveal the presence of elements such as hydrogen, oxygen, and sulfur within the nebula. Subtle color variations enhance visual complexity and provide insights into the nebula's physical conditions. The scene transitions into the vastness of deep space, characterized by its minimalist aesthetic. A single, bright star serves as the focal point in the otherwise empty space. The star exhibits a pulsating effect, varying in brightness to draw the viewer's attention. Pulsating stars exhibit a periodic variation in brightness. The brightness variation of a pulsating star creates a hypnotic visual effect. These brightness changes are gentle, not abrupt. The surrounding star field gradually diminishes in brightness and density. This visual effect focuses attention on a central, pulsating star. The diminishing star field enhances the prominence and activity of the central star. The spacecraft begins its descent back into Earth's atmosphere. The spacecraft drifts through layers of clouds during its atmospheric entry. Atmospheric entry involves controlled deceleration through aerodynamic drag. Dense cloud layers form the initial atmospheric boundary. Entering the atmosphere involves traversing through these cloud formations. The cloud layers create a visual representation of atmospheric density. Clouds are tinted with colors as sunrise approaches. Sunrise colors result from the scattering of sunlight by atmospheric particles. The degree of color tint depends on the angle of the sun relative to the Earth. The horizon line gradually appears as the sun begins to rise. The rising sun illuminates the calm surface of the lake. The original state of the lake is revealed as the sunlight increases. The lake's surface acts as a natural mirror, reflecting the colors of the sunrise. Reflection completes the visual journey, creating a harmonious blend of sky and water. The still surface of the lake enhances the clarity and intensity of the reflected colors. The Earth's night sky reveals countless stars, each a distant sun. Mountains and lakes form a dark silhouette against the starlit backdrop. Clear atmospheric conditions enhance the visibility of celestial objects. The Earth's night sky transitions seamlessly into the vast expanse of outer space. This transition showcases the relative proximity and connection between Earth and the cosmos. The visual pan emphasizes the continuous nature of space, extending beyond Earth's immediate environment. Vast fields of glowing stars populate the expanse of deep space. The continuous journey through space reveals the immense scale and beauty of the cosmos. Star fields are composed of countless stars, each a distant sun. Distant galaxies shimmer, enhancing the depth and scale of the cosmic landscape. The shimmering effect is caused by the dynamic interplay of light and matter within the galaxies. These distant galaxies provide a visual representation of the vastness of the universe. Nebula clouds are vast interstellar formations, composed of gas and dust. These clouds exhibit soft motion due to the subtle interactions of gravitational forces and internal pressures. The colors in nebula clouds are determined by the chemical composition and the light they emit or reflect. Shooting stars appear as transient streaks of light across the night sky. Light trails are created by the movement of celestial objects across the field of view. These phenomena enhance the visual dynamism and sense of movement in deep space scenes. Cosmic dust particles enhance the visual texture and realism of the deep space environment. The presence of detailed cosmic dust contributes to the depth and complexity of space visuals. Realistic rendering of cosmic dust particles adds authenticity to space simulations and visualizations. Radiant starlight beams illuminate the darkness of deep space. Starlight's ethereal glow creates a serene and awe-inspiring cosmic atmosphere. The beams of starlight pierce through the darkness, revealing the hidden wonders of the universe. Binary star systems feature two stars orbiting a common center of mass. The gravitational interaction between the twin stars causes them to rotate around each other. The slow rotation of twin stars creates a mesmerizing visual phenomenon in space. Parallax motion enhances the perception of depth in star fields. The relative movement of celestial objects provides a sense of perspective. This technique simulates three-dimensional space using two-dimensional motion. Subtle lens flares enhance the realism and visual appeal of starlight in deep space. Lens flares add depth and dimension to the celestial scene. The strategic use of lens flares creates a captivating and immersive visual experience. The animation maintains a calming atmosphere through slow, deliberate movements. Serene visuals contribute to the meditative quality of the animation. The overall effect is designed to evoke a sense of peace and contemplation. A spiral galaxy is a type of galaxy characterized by a central bulge, surrounded by a flattened disk with spiral arms. These galaxies are composed of stars, gas, dust, and dark matter, all gravitationally bound together. The spiral arms are regions of active star formation, making them appear brighter and bluer than other parts of the galaxy. The galactic core is a region of intense luminosity. Spiral galaxies exhibit intricate structural details. The brightness of the galactic core reveals underlying energetic processes. Spiral galaxies feature intricate arm structures composed of star clusters and nebulae. Star clusters within the galactic arms are gravitationally bound groups of stars formed from the same molecular cloud. Nebulae are interstellar clouds of dust, hydrogen, helium, and other ionized gases where star formation occurs. Nebulae are vast interstellar clouds composed of gas and dust. The movement of gas within a nebula is influenced by gravity, radiation pressure, and magnetic fields. Nebulae serve as stellar nurseries, where new stars are born from collapsing regions of gas and dust. Nebulae are vast interstellar clouds composed primarily of gas and dust. The drifting of gas clouds creates a sense of depth and immersion within the nebula. These clouds are the birthplace of stars, where gravity causes gas and dust to coalesce. Nebulae exhibit subtle color variations due to differing elemental compositions and light interactions. These color variations add visual complexity and depth to the nebula's appearance. The subtle color differences are caused by the emission spectra of ionized gases. The scene transitions to a minimalist deep space environment. A single, bright star is positioned at the center of the frame. The star exhibits a continuous, rhythmic pulsation in brightness. A pulsating star exhibits a gentle variation in brightness over time. This brightness variation creates a subtle, hypnotic effect. The star's pulsation is a periodic change in its luminosity. The surrounding star field gradually diminishes, drawing focus to the central pulsating star. Diminishing star field enhances the visibility and prominence of the central star's pulsation. The diminishing star field effect directs the viewer's attention to the dynamic behavior of the central star. The return journey commences, initiating entry into Earth's atmosphere. The spacecraft drifts through layers of clouds, navigating atmospheric conditions. Atmospheric entry involves controlled deceleration and navigation. The Earth's atmosphere features distinct cloud layers of varying densities. Dense cloud layers create visual barriers and affect light penetration. Passing through dense cloud layers simulates the sensation of atmospheric re-entry. Clouds are tinted with colors as sunrise approaches. The sunrise effect is due to the scattering of sunlight by atmospheric particles. The specific colors depend on the angle of the sun and the density of the atmosphere. The sunrise horizon begins to emerge, gradually revealing the calm lake. The initial state is characterized by a serene, undisturbed lake surface. The rising sun illuminates the lake, symbolizing a transition from darkness to light. The lake's surface acts as a natural mirror, reflecting the ambient light. Sunrise colors are mirrored, creating a symmetrical visual effect. Reflection completes the visual journey of light and color. The Earth's night sky is filled with countless stars, each a distant sun. Stars vary in brightness and color, reflecting differences in temperature and size. Constellations form recognizable patterns in the night sky, aiding navigation and cultural storytelling. The transition begins with a view of Earth's night sky, filled with stars and faint city lights. As the camera pans upward, the atmosphere gradually thins, revealing the increasing density of stars. The transition culminates in the vast expanse of outer space, showcasing distant galaxies and nebulae. The scene opens with a slow, continuous journey through the vastness of space. Vast fields of glowing stars are revealed, creating a sense of cosmic scale. The slow motion effect emphasizes the immense distances and timeless nature of space. Distant galaxies shimmer, adding depth and scale to the cosmic landscape. The distribution of galaxies reveals the large-scale structure of the universe. Light from distant galaxies provides insights into the universe's history and evolution. Nebula clouds are vast interstellar formations composed of gas and dust. These clouds exhibit gentle motion due to complex interactions of gravity, radiation, pressure, and magnetic fields. Nebula clouds serve as stellar nurseries, providing the raw materials for star formation. Shooting stars create light trails as they traverse through space. These light trails add a sense of dynamism to the cosmic scene. The gentle drift of shooting stars enhances the visual experience. Cosmic dust particles enhance the realism and texture of the space environment. Detailed visualization of cosmic dust reveals its complex structure and distribution. The presence of cosmic dust contributes to the overall aesthetic and scientific understanding of space. Starlight beams are electromagnetic radiation emitted by stars. These beams travel vast distances through space, carrying energy and information. The intensity and color of starlight provide insights into the star's temperature and composition. Binary star systems feature two stars orbiting a common center of mass. The slow rotation of twin stars creates a visually captivating celestial phenomenon. Gravitational forces dictate the orbital paths and rotational speeds of binary stars. Parallax motion enhances the perception of depth in star fields. The differential movement of stars creates a sense of perspective. Subtle parallax motion provides a more immersive and realistic viewing experience. Lens flares can add realism and visual interest to starlight in space scenes. Subtle lens flares enhance the visual aesthetic of distant stars. Lens flares contribute to the overall atmospheric effect of a space scene. The animation maintains a calming atmosphere through slow, deliberate movements. Serene visuals contribute to the meditative quality of the animation. The overall effect is designed to evoke a sense of calm and meditation. A spiral galaxy is characterized by its distinct spiral arms emanating from a central bulge. These spiral arms are regions of active star formation, containing numerous young, hot blue stars. The central bulge typically contains older, redder stars and a supermassive black hole at its core. The galactic core emits intense light, illuminating the surrounding spiral arms. The brightness of the galactic core reveals the intricate structure of the galaxy. The spiral arms are organized around the central core, showcasing the galaxy's rotational dynamics. The spiral galaxy's arms reveal intricate structures of star clusters and nebulae. Star clusters are gravitationally bound groups of stars formed from the same molecular cloud. Nebulae are interstellar clouds of dust, hydrogen, helium, and other ionized gases. Nebulae are vast interstellar clouds composed of gas and dust. The movement of gas within a nebula creates dynamic, evolving structures. Nebulae are often sites of star formation, where gravity compresses gas and dust into new stars. Gas clouds drift slowly, creating a sense of depth within the nebula. The drifting motion of gas clouds contributes to the immersive experience. Nebulae are composed of gas and dust, illuminated by stars, resulting in visually stunning formations. Nebulae display subtle color variations due to differences in elemental composition and ionization. These color differences enhance the visual complexity and aesthetic appeal of nebulae. The subtle color gradients reveal the underlying physical processes occurring within the nebula. The scene transitions to a minimalist deep space environment, emphasizing vastness and isolation. A single, bright star serves as the focal point, its rhythmic pulsations creating a sense of cosmic rhythm. The pulsating star symbolizes the dynamic and ever-changing nature of the universe. Pulsating stars exhibit a gentle variation in brightness over time. This brightness variation creates a subtle, hypnotic visual effect. The gentle pulsation is due to periodic expansion and contraction of the star's outer layers. A star field provides a backdrop of distant galaxies and nebulae. The star field gradually diminishes in brightness, drawing focus to a central star. The central star pulsates, indicating dynamic energy and activity. The return journey commences as the spacecraft enters Earth's atmosphere. The spacecraft drifts through layers of clouds during its descent. Atmospheric entry involves navigating complex aerodynamic forces and thermal conditions. The Earth's atmosphere contains multiple layers of clouds, varying in density and altitude. Dense cloud layers create a visual barrier, obscuring the Earth's surface from above. Descending through dense cloud layers simulates the sensation of atmospheric re-entry.